This is Viterbi Voices.
Coming to you from the University of Southern California, Viterbi School of Engineering.
We're here to give you the inside scoop about research, classes, student life, and so much more.
All of these shared from our students, faculty, and other members of our USC community.
Well, hello again, everybody. Welcome back into the Viterbi Voices podcast. I am one of your co-hosts. My name is Paul Ledesma, Director of Undergraduate Admission here at the USC Viterbi School of Engineering.
And my name's Emily Powis, and I'm a senior studying biomedical engineering.
And joining us, I think this is your first time on the podcast, mystery guest. Introduce yourself.
Hi, everyone. I'm Matthew Kloss. I'm a senior studying biomedical engineering at USC. I'm excited to be here for my first time, indeed.
Yeah, absolutely, Matthew. So you're a senior studying biomedical engineering. Tell everybody a little bit more about yourself. Where are you from? What else you do on campus?
Kansas City, Missouri, on campus. Other than my VSA work, I'm also a part of the Club Frisbee team, a member of the Associated Students of Biomedical Engineering, and involved with Greek life.
All right. Very cool, Matthew. Thank you. So, Matthew, you bring to us an episode that is a little unique, but I think very perfect for our times. Tell everybody what this episode's about.
Okay, so this episode is about a few people that I have met on campus. Everyone's always getting up to something very interesting here at USC, but over quarantine, people had even more free time. So in this episode, I interviewed a few of my friends about some interesting projects that they ended up doing over quarantine when they were all stuck at home and trying to figure out what they could do with that time.
Yeah. So the last year and a half has been interesting for everybody. And I think with highly creative technical people such as USC engineering students, I think everybody got a little crafty, a little creative in their own unique ways. And I'm excited to hear a little bit more about some of these quarantine projects that your friends got up to. And then on the back end, I definitely want to hear whether you guys got into anything like this or something that maybe you still want to get into. So let's get out of the way and hand it straight over to Matthew to walk us through he and his friends' quarantine projects.
Alrighty. Hi there, Reuben. Thank you so much for coming on with us today. If you would just like to introduce yourself, that'd be fantastic.
Sure thing. My name is Reuben. I'm a mechanical engineering major at the University of Southern California, and I'm happy to be here.
Awesome. Thanks for coming. So today, we're going to talk about the incredibly cool project you did over quarantine, your laser harp. So do you want to just give a brief overview of what that is? I'm sure laser harp is a pretty esoteric term to most people.
Sure thing. Yeah, the long and short of it is like this. It's a musical instrument that's just like a harp, but instead of having strings that you pluck, it's got laser beams that you interrupt with your finger. And it's completely electronic, and it was completely designed by me. And it was a quarantine project that I just finished at the very end of 2020. And it was a total blast to get to do. I'm really into music and I'm really into engineering. And so it seemed like a no-brainer for me to combine music and engineering into a laser harp project.
That's awesome. So you how long about did this take you to from start to end, from conception of the idea to actually getting it done?
There's two answers to that question.
Okay.
Because I actually built the laser harp 3 times. The first time I built it was all the way back in high school, and it was like just to see if I could build a laser harp, but I wasn't satisfied with the design. So I rebuilt it again in the summer of 2019. And then I rebuilt it again over the pandemic until I had gotten it to a place where I was super satisfied with the design and the makeup of the harp. Over the entire course of these entire 3 builds, it was 3 years, but the final laser harp, which is probably the one that you're most familiar with, took me about a year to make.
Wow. Yeah, that is crazy. So then that's been on your mind for a while. Then this has been a long-term project for you. What originally inspired you? Was it just, did you see something online, or how did you find out about laser harps in general?
So the idea of a laser harp wasn't totally invented by me. I think that the earliest laser harp goes all the way back to, oh man, I'm gonna have to check on Wikipedia, but laser harps have been around for a while. My idea was to create a laser harp where I had more control over its capabilities. Like, for example, I wanted to make a laser harp that had a pitch bend controller, the way that some electronic keyboards have a pitch bend dial. And as far as I knew, laser harps in the past haven't been able to do that. And the way that it all started was I was part of an engineering project camp in the summer of 2017. That was the summer that I started building the first version of the laser harp. And they allowed us to choose from a catalog of different project ideas. And I wanted to choose the laser harp, and they said, sorry, you're not allowed to be making that for whatever reason. They probably had, I don't remember it that well. They probably had some very legitimate reason for saying you're not allowed to build a laser harp. And so I said, fine, I'll play by your rules. But as soon as I'm done with this camp, I'm making a harp myself. So that's how it started.
That seems like a pretty good reason to start it. Yeah, I guess couldn't let them keep you down. I mean, you proved them wrong at this point, for sure.
I sure hope so.
Yeah. So it actually has like full pitch bend. So it's more than just the note when you pluck the strings. Is there any other additions? It can actually bend pitches. Is there anything else that's different from, your bog standard harp?
I tricked it up with all the fixins, or at least I did my best to. It's got a joystick on it. And so the joystick has two controls, right? Because you can thumb it left or right, but also up and down. Left and right changes the pitch gradually, just like a pitch bend dial on a keyboard. And up and down changes the octave. So since there's only 8 strings on the harp, it's obviously at some sort of disadvantage to a real harp, which has probably 100 strings or something like that. But you can toggle through what octave you'd like to be playing in by thumbing the joystick up and down. And you can also toggle what key you'd like to be in, because there's a transpose button. For other words, there's a transpose up button and there's a transpose down button, as well as a button in the very center of the up and down transpose buttons. That's a mode button. And the mode button allows you to transfer between being in a major key, a minor key, or a pentatonic key. And so it's got a whole bunch of different mode settings for different musical applications. And the most exciting feature of the new harp that I was proud of was the headphone jack. Let me rephrase that. It's not a headphone jack. The most exciting new feature of the harp is that it's got an audio output jack, the same way that an electric guitar has an audio out jack. And you can plug a guitar cable into that and send the other end of that cable into a interface if you want to collect the audio coming out of the harp and modify it with a DAW or with a digital interface. But you can also send it just into a guitar amp if you want to amplify the sound.
That's awesome. Fully an electric harp. Really makes some big differences there. That is so cool. All right. To get more into the meat of it, do you want to would you be willing to walk us through your process of how this kind of went on the most recent iteration? Like how you got the hardware and software set up, what kind of some of the falling blocks were, just a quick overview of that.
Yeah, absolutely. So this was coming off the heels of the second iteration of the harp. In the second iteration, I had the responsibility of building the interior and the guts of the harp, while I had shared the responsibility of building the harp with my friend Luke from high school. And his part was building the outside. He's an architecture student. So he had a wonderful design that he put together that served as the casing of the harp. And so much of the electronics that I needed for the new harp had already been mostly developed. And it's all based off of Arduino. You familiar with Arduino?
Yep. Absolutely.
Yeah. It's a great platform for setting up circuits and for managing electronics in different ways. And each string has 2 components. The first component of each string is the laser. And it turns out that you can actually just buy laser diodes on Amazon, and they're not even very expensive. And they work pretty much identically to how an LED works. And the lasers are all shining down their light onto a photodiode, which is an electronic component that's able to determine how much light is entering it. And so that's how the harp is able to determine whether or not a laser light is being blocked by your finger. What it's measuring is a drop in light that's entering the photodiodes, and there are 8 of them. The hardest part of getting the harp to work was coming to the realization that the photodiodes are not 1-bit binary in the same way that a switch is 1-bit binary. What I'm trying to say is that they don't send a yes if light is coming in and a no if light isn't coming in. What they send is a number between 0 and 128.7 that represents how much light is coming in. So in order to get the harp to work, the harp has to know on some level how much ambient light there is. And the workaround that I found for that is as soon as you plug in the harp, it turns off the lasers and it takes a low light reading of how much light is in the area. Then it turns the lasers on and takes another reading of how much light there is coming into the sensors with the lasers on. And at every moment, it's comparing its current state of light to both the low light conditions and the high light conditions. And if it's closer to the low light conditions, it makes the assumption that the light is being blocked.
That is real clever. That makes a lot of sense. Yeah, to figure out all the software I'm sure that code was pretty finicky to make sure that it works properly with the low light settings and the high level portions of that, especially the calibration.
I mean, as an engineer, you're probably familiar with like how in the weeds you can get with software.
Yeah, absolutely.
And that was the toughest part. I should mention, this is sort of getting even more into the weeds of it, but I should mention that if you want to control a pin with Arduino, you can only send out 3.3 volts per pin. So if I wanted to be able to do that thing that I mentioned at the beginning, where it keeps the lasers off for a second and makes a reading and then turns the lasers back on, I needed to be able to control the lasers with a pin, but since the pins could only send out 3.3 volts, the laser lights weren't bright enough. So then I had to figure out how to get an electronic switch to be controlled by the Arduino, but powered by something other than the Arduino. And originally I had it being powered by a battery pack. And then at some point I was able to find a way to get more voltage out of the Arduino. You know what? It's been a long time since I did this, so I don't remember all the details. The point that I'm trying to make is that it ended up being really, really difficult to manage all of these different needs that the lasers had.
Yeah, that sounds real complicated, to be honest. Pretty good amount of that went over my head. Biomedical engineering doesn't lend itself too terribly to all of the electronics sometimes. But that is certainly sounds like you encountered a few problems there, but sounds like you figured them out pretty well. Just to follow up with that, so obviously you said you built the first one over the summer while you were in high school, but most recently this was obviously a quarantine project. How was that doing it during quarantine? Were you taking classes at the time, or was it just kind of inspired by having that extra time on your hands, or do you think it would have gotten done anyway, since it was something that you'd been working on for a while?
On the topic of time management, the harp became to me a sort of time glue, in that I would work in time to work on the harp just in the in-betweens. There was never any set schedule, and there were no periods of working on the harp. It was just something that I would do every time that I got a free moment, which happens to be, in my opinion, the best way to have a hobby. That's also how I approach making music, just in general, is it fills in all of the little cracks in my schedule, and I wouldn't have it any other way. Over quarantine, I did end up having a little bit more free time than I have, say, this semester now that we're back on campus. And I did a lot of the work on the harp in quarantine over the summer when I had a whole bunch of free time. On top of that, I also took a semester as a part-time student over quarantine, because that was the time to do it, if you know what I'm saying. And that gave me extra time to work on the harp and extra time to be sure to finish it before the end of 2020.
How do you think that your time at USC, with mechanical engineering and all the other skills that you've learned in college, changed your outlook on this harp? Obviously, you started in high school. Was there anything that you learned throughout school that kind of helped you with this final iteration and helped figure it out? Any specific classes or clubs or anything like that?
Yes, 100%. It all comes down to the fact that I lost Luke in between the second iteration of the harp and the third iteration of the harp. The building of the interior and the exterior was up to me when it came to the third harp. In the second harp, I only was responsible for building the guts. But for the third one, it was up to me to build the interior and the exterior. And I built the exterior using 3D printing. All of the resources and the knowledge that I needed in order to make that 3D printed casing exterior come to life, I can thank 3D4E for, which is a club that I've been with since my first semester. It's an excellent club. I'm on the e-board and I'm having a really great time. And I spent a whole lot of my free time in the 3D printing lab while I was building the harp before I was kicked out because of the virus. And that's what gave me the resources and the time and the space to get good enough at 3D printing where I could build the exterior of the harp.
That is very cool. Yeah, definitely always a good time to plug 3D4E, a club that we're both a part of. It's a lot of fun. And Reuben is indeed exceptional at showing off some of the really cool things that you can get done with it. To follow that up, so you talked a lot about how you really enjoy both music, but you're also an engineering student. Obviously, that's not exactly the most common of combinations. When did you start doing music, and how do you kind of factor it into your life now that you're, busy with engineering and everything?
Well, music is a big part of my family. I've got a father who's a casual musician, and a lot of folks on my mother's side of the family are professional musicians. And it ends up being sort of tough to juggle being a musician and an engineer because of the fact that they're sort of disconnected, and the fact that to have two passions means to make sacrifices for one in favor of the other all the time. In my dreams, there's a way where someday in the future, I get to combine music and engineering in the way that I did with the Laser Harp project, and then turn it into a career. That's the golden emerald at the end of the road for me. But I still haven't found out a really clever way of making that work, and it's an ongoing brainstorm in my life.
Yeah. So you were talking. You said just previous to this, you had been making music with some friends. How do you currently address music in your time at USC? Like, what kind of things do you find to feed that passion while you're here?
There are a whole bunch of creative people at USC, and if you end up keeping your eyes open and your heart open to creativity, it'll come to you. Very excitingly, I recently got hired to make music for the Viterbi School of Engineering. There's this very interesting man whose name is Adam Smith. I believe that his job is he's in charge of all media that comes out of Viterbi. And he found me through a recent article that was written about the laser harp in the Viterbi newspaper, and hired me to create songs that are musical adaptations of research papers that are put out by Viterbi students and staff, which is a pretty zany idea, right?
Yeah, that seems a bit crazy. Yeah.
Yeah, but so far it's been just so much fun. I'm really just in the beginning stages of it, but I've already started writing this one song that's based on a research paper about laser light communications and their ability to replace radio frequency communications in certain circumstances. And I've also written a song about RNA, and hopefully around the time that this podcast comes out, it should also be coming out. And so go check that out if you can. I think it's a fun song, and I think a lot of people are going to be excited to hear it.
That is incredibly interesting. So just to follow that up, is it essentially you're reading over these papers and then kind of interpreting and writing a song based on that? Is that the idea?
Exactly right. It's kind of like Schoolhouse Rock in a sense. I'm like trying to bring these kind of complicated, heady research papers down into a consumable musical space.
There you go. That seems like a pretty good way of putting together some of those passions right there, getting to find those papers and then translate them into a musical format. That is so cool.
Thank you.
That sounds like it'll be a great time. I mean, that'd be completely over my head first, but yeah. Are there any interesting stories that cropped up from making that harp? I'm sure that it was a long process and a lot of it got pretty hairy in there for a minute.
Yeah, exactly. There was one sort of silly thing that happened. I know that I mentioned earlier that I never made a schedule for myself and that I just worked on the laser harp when I had a moment. But there was actually a point where I gave myself a deadline, which was out of character for me. But what it was I had started working on the demonstration video, and I had it about a third of the way done, and I had already finished designing the title card of the first frame of the video that says Reuben Levine's Laser Harp 2020. And I didn't want to go back and change that 2020 to a 2021. And it was November, and then it was December, and I was still just putting the last finishing touches on the harp and the demonstration video. And the one thing that I made myself do was finish it before the end of 2020, just so that I wouldn't have to go back and fix that title card.
Sometimes it's important to have the deadlines on the small things. It's the aesthetics. The aesthetics matter.
Agreed. Yeah, that's a good point. 2020 is it's a much more symmetric year.
Yeah.
In terms of the way that it's written.
It certainly also carries a lot of weight now in like seeing that on a date. You're always going to be like, oh, this is something that happened that year. It's historical significance.
Yes.
Almost.
Totally historical significance. And lo and behold, I got it done in time. So booyakasha.
That is definitely a win. So I was just wondering, how is having the finished product? Like, what are some of your favorite songs to play on it? Is that something that like you can, I mean, obviously, as you said, it had a whole range of octaves, different keys, harmonics, things that go over my head because I know only a little bit about music. But is it pretty established, or what songs were you interested in playing on a laser harp?
This sort of tragic story that I have to tell is that let me rephrase that. I spent a lot of quarantine home alone, like everybody did. And it's not so easy to jam on a laser harp without a rhythm section, like without somebody to accompany you on guitar or piano. And I didn't really have that until the end of quarantine. But by the time that quarantine was ending, I was coming back to Los Angeles, and I didn't have the harp anymore because I left it in New York. It's not particularly easy to ship across the country, as you can maybe
Yeah,
imagine.
makes sense.
So the unfortunate truth is I didn't really ever get that much time to jam on the laser harp or show it off. But maybe sometime in the future, I'll be able to bring it out to Los Angeles and get to play it and show it off for my friends.
Fantastic. Well, that sounds like a fantastic story, and it sounds like there's a lot more to maybe come from that laser harp. I think that's about all we have for you today. Thank you so much, Reuben, for coming on. It's been a pleasure having you and hearing about this really cool project that you've done.
Thank you so much, Matthew. This has been a whole lot of fun.
All right, Jack, thanks for coming on. Would you mind introducing yourself?
Of course, happy to be here. Thanks for having me, Matt. So my name is Jack Cook. I am currently a master's student in product development engineering, and I did my undergrad in biomedical engineering with a mechanical emphasis. I just graduated in the spring of 2021. So I'm just doing my PDP program right now and hopefully finishing this up in spring of 2022. And I've been at USC the whole time. It's been great. So that's a little bit about me. I'm from Reno, Nevada. Love it there. So
yeah, love it. So how have you been? How's your day been going?
Oh, it's been going pretty well. I went down to San Onofre and surfed a little bit. So trying to make the most of being in LA, getting all those local perks. So it's been a good day.
Definitely always fun. Yeah, always been a big surfer if I remember correctly. Yeah. So yeah, would you mind giving us a brief overview of the project that you've done?
Sure. So during quarantine, the main project I was doing was focused on whiplash associated disorders, or just whiplash. So basically, we didn't do any hands-on work because it was all remote, but it was the perfect project to take on during quarantine because we were going through review articles and other people's research to kind of determine where this research has come from, where it's headed, and sort of the main players in the field, and who really has the best, most replicable and most accurate models of whiplash, and what they've sort of determined about what causes it. Because I don't know how familiar you are with it, but whiplash isn't really,
not particularly.
It's not a really well-known phenomenon. Like, people can usually get away with claiming that they've gotten whiplash from a car accident. It's very difficult to prove that you actually got whiplash because there's sometimes a little bit of inflammation, but no one really knows the root cause of that pain. And it's really hard to determine. It's not like a bone is breaking or a ligament is tearing. So it's really interesting, and it's a field that still has a lot of exploration that needs to be done.
It's really interesting. I mean, I've suffered from whiplash before. I mean, like, I've been in a car accident, and
Yeah, I've had very minor whiplash before too. I haven't really felt the full effects, but I know people who got medical exemptions at school while I was in high school because they got it from something like I think they were jet skiing and stopped really hard. And so they came back into school and they were allowed to use their computer for like test taking and stuff because they couldn't move their head downward. So so it was bad enough to where they literally couldn't move their head downward. They could move it side to side a little bit, but it took them about a month to heal. So that was my first exposure to whiplash, was seeing one of my friends have that sort of issue.
That's crazy. Yeah, no, I always thought that whiplash was just like vague pain that you get after your head moves around.
Yeah, and that's basically what it is. Like, it's, long story short, with all this research, it's very difficult to understand what's happening with whiplash. You can't do many clinical studies with it because you can't give people whiplash, obviously.
Makes sense.
So it's really hard to tell what causes it. And by the time you have a case study from someone in a car accident, you don't really know the exact speeds that were causing it, where the degrees of rotation were. Those are all important things to determine like what the root cause is. And it's hard to do that in hindsight when you talk to someone about it. So
Yeah, I guess essentially then, can you not model the neck effectively enough to have a reasonable model that you could?
they can. That's the main thing that they've been really trying to do, is get the best possible model. And that's really what our research was about. So we started it really broadly. Basically, the way that we got into this research was, I was taking a class with Peter Halligan and Natalie Kistler. We all went into a group project together, and we decided to do it on whiplash. So that was like our final project in orthopedic biomechanics in BME 404. So we enjoyed the research while we were doing it for the class. And towards the end of the semester, we had a meeting with Dr. Abrams and just asked him if he could give us some feedback on where we were before our final presentation that was worth a pretty big portion of our grade. And that was when he asked us if we would be interested in continuing the research with his lab. So it was kind of an informal, he said, hey, do you want to keep doing this next semester? You can take it for credit if you want to. And so I got directed research credit that counted as a tech elective for me for continuing this research in the spring of last year.
Right. Okay, so he must have been pretty pleased.
I think he was pretty happy with it. And it was nice because all three of us had good chemistry on the project. We all were carrying pretty equal weight, which is, as you know, kind of rare in group projects to have a good dynamic like that. So I was really happy when they both decided to continue working on it as well. And we're all still involved in Dr. Abrams's lab to some extent, but at this point, we haven't worked much on the whiplash research since the end of the spring semester, just because they have a lot of other projects. And now that we're able to be in person, they are doing more, they're doing more hands-on research with tensile testing on bones and things like that. So it's kind of gotten pushed to the wayside, but we're hoping to continue it.
Yeah, that makes sense. I mean, definitely all those professors' labs always seem like they have like 18 different things running at the same time. So I imagine something that's just online, just mostly research-based wouldn't be exactly the most coveted portion.
Right. And I think everyone's just happy to get that hands-on work again after being online for so long. So Dr. Abrams wanted to get them that experience. And my main capacity right now for him is being his teaching assistant for orthopedic biomechanics. So I'm not doing much research right now, but I'm helping him out with that class.
Right. So all of you have ended up very involved with him then after that class, and just this project kind of led a lot of that. Yeah. Definitely really helped you get a lot closer to that professor. So what was the process like of actually going through this? So you were essentially, sounds like primarily a research project then, and a lot of different things to find. What was the actual process of your research looking like?
Well, we had a very similar process every week. So we would meet with Dr. Abrams and his colleague, Dr. San Giorgio, who works at UCLA. They're both combined. This lab isn't technically a part of USC, it's more a part of UCLA. And he's a professor at USC and she's a professor at UCLA. So they were both kind of leading the project, and But they gave us a lot of freedom. So basically, since we already had the foundation of this project from our report that we did in his class, he basically said, all right, you guys can continue this however you want to. Let us know what your plan is, and we can meet weekly to give you feedback and kind of see what direction we want to go with this. So we took a break for most of December, and then when we got back to school in January, or virtually back to school at least, we started having weekly meetings with him and Dr. San Giorgio. And basically it was really overwhelming at first, because the only thing we could think of to do is basically search in all of the academic databases whiplash and trying to narrow it down from there. Even if you narrow it to only academic articles, only peer reviewed, only biomedical or involved in this field, which was hard to do. There were, for some reason, a lot of whiplash articles were about like the movie Whiplash and some music stuff. So we had to weed all that out of there, but we still ended up with about 700 or 800 results. Wow. So it was, like I said, really overwhelming at first. And so the first thing we decided to do to help us move in a little bit better direction was to focus on one type of whiplash modeling. So there's a lot of different types, and the main ones are, they use crash test dummies with really detailed upper like cervical spine models to do it. That's one of the more modern ones. The most modern and probably most researched right now is finite element models. So it's all 100% computer models. But the problem with those is those are completely based on studies from the third type of model, which is cadaver models. So they basically just get a human cadaver, take the upper part of the spine and put it on a sled and just run it really fast and see what happens.
I shouldn't be laughing at that. Wow. That's a crazy, wow. That must have taken a lot of clearances to figure that out. I guess that is what you check out when you say, give my body the medical science.
It is, but it was really interesting to see like the pictures and their processes. They were very detailed, very professional, except for some reason, this one lab decided to keep the full human heads on there too. I don't know how much I should be talking about this on a podcast or.
Yeah, that might be a little bit gruesome, but wow, that's
yeah. So I mean, that's just a part of research. Every research, or not every research lab, but a lot of research has to do that sort of thing to get to a good result. So that they thought that was the most accurate way to model it, and I see their logic, but it still just seems like a little much. So most of the best models used a weight that modeled the head. So they like would put the center of gravity where the head would be, fix that on top of the spine that they put on the model, and that was how they did it.
Yeah, it makes sense. Just kind of assuming that the head is a sphere, put it in the center of gravity, some quick little physics assumptions.
Yeah, that, and most of the labs figured that kind of assumption wouldn't affect their research too much. Like the benefits of doing that they outweighed the risks of potential miscalculations. So that was, so basically what we focused on was those sort of cadaver models, and our research started as kind of comparing the different models and what they're like and their effectiveness, and then ended up sort of going into the direction of a review article on the history of these cadaver models and their continuous improvement, talking about the big players in the field. There's one lab at Yale that probably published like, I don't want to miscalculate, but I would say like 60 to 70% of these like really effective models, or they were the foundation of other models. So they were leaders in the field. Yeah.
So there were 3 different types of models, you said, right? The first one was the crash test dummies. The second was the networks,
the finite element. Yeah.
Finite element networks. So kind of like a simulation, predicted simulation almost. And then that was based on the cadaver models though. And that's what.
Right. So we were focused on the cadaver models.
Right. And so is this lab at Yale. So they made different advancements. So like, how do you advance on that, just in the ways that you iterate
It's really interesting how they advanced it. So I think the first one that they did was in probably 1996, maybe 98. And it was as simple as it could get. Basically, spine on the sled, move it at a constant speed or acceleration, and then stop it and use cameras to like slow or fast motion cameras to determine the angulation of the spine and
Okay.
what that could cause. Take a look at all the different ligaments that are still there and what's involved, and measure some of those distances and then the strain between the elements, like between the different vertebrae. So that was the first one. Then it improved to incorporating a few more wires that acted as different ligaments and things like that. Having a few more sensors and different variables that they wanted to test. And then it moved on into also including springs that acted in the same way that your muscles would act. It was supposed to replicate like a muscle force in your neck. So trying to get even more advanced. So basically they just kept adding more and more pieces to their physical model to try to replicate the human neck as best they could with all these different mechanical engineering strategies. So it was really, and it's a very linear like timeline that we found. It was hard to dig deep into that and see, but once we started going in that direction and focusing on that, we found that that lab and a couple of others had a very constant progression in just making their models better and more detailed. So I thought it was pretty cool to learn about that.
Yeah, no, that's really interesting. I mean, they obviously when you started it sounded very only skeletal structure based, and obviously that doesn't encapsulate the entirety of what the neck does. But how do those springs, so you said they use springs to try and mimic the muscular force, but is there any way that they tried to mimic the pain or the effect that would have on the actual like muscular cells, as those would obviously get a little bit more damaged than, or is it determined that whiplash is primarily a skeletal structure issue?
Well, that's the thing, is in all of these models, they were, a lot of the time they would improve the model and also change what they're trying to focus on for that model, like what variable they think caused it, because they didn't focus on just one potential factor. They were doing things like muscle, they were doing things with the ligaments, and basically they were just trying as many different variables as they could to find some sort of correlation, basically between acceleration, or like how hard something would have to stop to cause a certain strain, and then like finding the relationship between these different factors. So with the muscles, like with the springs, they would almost always assume, which isn't really a correct assumption, that the neck was relaxed at the time, just because it's easier for them to measure. So it's just like their muscle force is basically just a loose like neck muscle.
Okay. So they just always assume an unexpected crash.
Almost always, yeah. And there were a few studies where they tried to replicate like your neck seizing up when you're expecting to be hit or something like that. And they had slightly different results. But yeah, that's kind of what they were doing, was just changing their variables as they improved and trying to figure out the root cause.
Okay, so yeah, so when you talk about the models improving, that's more on their ability to take into account a number of variables, because obviously they don't really have a error. They can't compare it necessarily to actual whiplash very well. It's more just that they've improved in their ability to test a number of different things.
Right. And like I said, as that improved, I would say it started to kind of plateau around 2015 or 2016. And that was when the finite element models started to really rise. And I think there are a lot of factors that could have caused that. One is that there was some scandal in one of the research labs, not one of these ones in particular, but one in the US, with like kind of black market, like cadaver research, where they basically, it made it really hard to get cadaver models after that. And so it was obviously more difficult to do these research studies if they couldn't get any more cadavers. And the finite element models had all of that information that they had already calculated from the cadaver models, and most of the labs focused on improving that technology and going completely digital. So that seemed like about the time where it ended. And that was kind of where we were when we left off our research in May, was getting to the end of all those cadaver models and really trying to figure out the correlation between them, who was collaborating with who, what sort of models had certain strengths and certain weaknesses. And we were just kind of synthesizing all of that into a research review paper to discuss it. So it's obviously, since it was done by 3 undergrads who don't have much of a focus in whiplash, it wouldn't be like published in Nature or anything like that. But we were hoping when we finish it to get it published in some sort of smaller journal that focuses on those review articles. And it would just be an interesting read for people like orthopedic surgeons and maybe some others who are interested in this sort of research.
Yeah, definitely. So at this point, it's just it's pretty much there, but you guys are just putting some finishing touches on it before you try and send it out for publication.
Right. We want to just go back through and make sure that we didn't miss any really important labs, because like I said, there were just so many results that we could have overlooked something that was extremely important to this whole process. Yeah. And we also want to consult with a few other like surgeons, people who are experts in the field, just so that we know that our wording is correct and we're understanding these models correctly. So there are a few more pieces that we need to finish up before the paper can be sent for review.
Yeah, I mean, that's also crazy. I mean, obviously that's a ton of data to trawl through. I mean, together we've done smaller projects on research, but 700 articles and over, you said almost 100, you said how many years? What was the range on the years for when they started looking at these things?
Well, for these particular cadaver ones, there were a few like preliminary ones that were in the 70s and 80s, but it was mostly started in the 90s. So okay. about 25, 30 years.
Yeah, still, that's a long time to be looking over research, especially with different labs. I assume you were taking them from labs, I mean, in the US, throughout. Was there any research done was it primarily US research that you ended up finding, or were there other labs that were relevant?
There were a lot of other labs. That's another problem, is we could only access the papers that were published in English. And fortunately, a lot of the European countries publish their papers as an English version too. But there could have been some research done in somewhere like China that we just never got to see because it wasn't published in English. So that was one way that we refined our search results. And that's a disclaimer that we already have written in our paper, is we may have overlooked that. But there was one lab that was in Canada. There was one, I believe, in Norway. There were a few European ones too. So that's so yeah, it was really done all over the world. But those labs tended to collaborate with the US labs, particularly the Yale lab, because they were really the leaders in the field for a long time.
Yeah, 60 to 70%. I imagine everyone was clamoring to collaborate with them.
Right.
Probably not exactly them. I mean, obviously there's a lot of publications, but probably not the biggest field when it comes down to figuring out who's involved in trying to figure out whiplash.
Exactly.
Wow. Either way, that sounds like it was a crazy project. That's a lot to be putting into it. And it sounds like you guys found out a whole lot, even if obviously it might not be definitive, but I mean, you certainly clearly have a lot of knowledge on it at this point.
Yeah, well, it was a big time commitment last semester, but I really enjoyed doing it. So whenever I didn't have too much work for my other classes, I would just start basically trolling through those databases to look for new articles and try to read through them as much as I could. Those, which, as you know from some of our other classes, it can be really time consuming to get a full grasp of a journal article. But which class was it? BME 202. Yeah, that one really prepared me well for this, actually, just from all those articles that we were required to read for the journal clubs. Just getting to know that process of reading through and learning how to effectively skim sometimes when required. That was super useful for this process too.
Yeah, I feel like that's something that's really underrated that we end up learning in classes, is just how to read a journal article. It doesn't seem like it would be a learned skill, but yeah, there's definitely a lot. I imagine there was a bit of a switch even from going from like what we were doing into it to, the neurological models and neurological papers primarily, to just orthopedic models. Do you notice any differences in that, or is it mostly still, I mean, same structure?
I would say the main difference I noticed was being able to comprehend the orthopedic ones a lot more, just because of my personal knowledge of that sort of thing and the mechanics behind that. They used a lot of mechanical engineering terms for that sort of thing. So I was more familiar with that than as opposed to the neurological models, where it was a lot of neurotransmitters that I would usually have to look up a second or third time if I didn't know much about it. And then that whole field just conceptually to me didn't click as well as orthopedics. So that was the main difference I noticed, was being able to get a little more of an understanding quickly. But it was definitely more satisfying to learn about those neuroscience ones, because it was something I had absolutely no knowledge of and felt like I had learned something completely different and new when I was reading those ones for class.
Yeah. So do you think that having this time online, obviously in not quarantine fully anymore, but during that COVID semester, was beneficial to actually doing this research project? I mean, obviously reading those articles, like you said, takes a lot of time, and you were doing it in between, but do you think that you would have ended up being able to do this research review with the same amount of rigor had you been doing classes normally?
I honestly don't think it would have ever happened if we were doing classes normally. The main reason for that is, first of all, before COVID happened, I was really committed to another research lab on campus, and I was working in there for a long time. Even after all of the isolation and the quarantine, I went in a few more times, but it just became increasingly difficult because of the restrictions, and one of our main projects had just winded down. For context, this lab was involved in nanotherapeutics, so it was more on the chemical side of everything rather than this orthopedic side, kind of synthesizing peptides and looking into plaque buildup and kind of doing that sort of modeling and creating some new research and development in that field. So I really enjoyed it, but that was my focus before this project. And unfortunately, just because I spent a lot of time during our virtual semesters at home, I couldn't commit to going in there full time anymore. And like I said, one of our projects had just winded down, so it seemed like a good time for me to kind of explore something new. And I just knew that in that lab, in that setting, I couldn't really effectively work from home. So it was just time to try something a little bit different and a little more focused on the mechanical side, like I wanted to be, because that's sort of what my emphasis was in BME.
Yeah, definitely. It sounds like it would be a big switch over to go from that fully chemical to basically almost an entirely mechanical project. But I know that you, I'm sure, had a pretty easy time with it.
I enjoyed it, but it was, like I said, I don't think that project, just to answer your question, I don't think it would have happened if we were in person, because even if I did decide to switch over to working with Dr. Abrams, I think he would have had us do more of the in-person activities. So he wouldn't have had us sitting at home to review articles. He really likes the hands-on exposure, and he wants us to be in the lab. So that's probably where most of our research would have been.
Yeah, that sounds pretty reasonable for orthopedics. It is something that for most orthopedic wounds, you kind of can study that pretty hands-on and be a little bit more demanding and everything. Whiplash is kind of unique in that, I would imagine, that it can't be modeled as well. Well, yeah, that sounds like a really interesting project. I mean, you clearly have learned a ton about it. I've learned a lot just talking to you about it just now, and hopefully our listeners appreciate it too. I know it got a little bit hairy in there with gruesome cadaver talk, but hopefully our engineers aren't too squeamish. I guess us biomedical engineers can be a little bit weird about it sometimes.
We don't realize what we're talking about could be a little gruesome, just because that's just how our field is, I guess. But it's I never had to really deal with it personally, just because it was all, like I said, kind of the virtual research, so I was removed from it. But it's just a part of the research, and it made really significant contributions to the field that we use now. We wouldn't be able to do the finite element without it. So
yeah, absolutely. And definitely sounds like your research and the thing that you put together, I hope it gets published soon, and sounds like it would be a good resource for someone trying to look into doing more research on it. You've done a lot of the heavy lifting on that part. Yeah, well, thank you so much, Jack, for coming on. I mean, I've learned a lot, and that's really great. It's a really interesting project, and I'm sure it'll hopefully, honestly, that's something that I might keep an eye on in the future, is just try and see where Whiplash goes. Maybe in
Yeah,
10
you
years we'll
should.
know what happens.
It's an interesting field, and I appreciate it, Matt. Thanks for having me on, and hopefully talk to you again soon.
And we're back. Thank you so much, Matt, for that episode. I was wondering, has this inspired you to start any projects on your own?
Well, now that we're out of it, it certainly feels like school is ramping up now that we're back on campus. But
Yeah.
it certainly makes me wish that there are certain things that I had spent a little more time on. There really was a lot of free time in that area, but it's really inspiring, like what people can do when you really put your mind to it. It's very impressive what is accomplishable just on your own in your bedroom with just a little bit of free time and access to Amazon.
Emily, what did you do? Did you do anything different or unique or creative?
I guess like I got really into crocheting, like little animals and stuff. And I sold them for charity, but it wasn't like engineering, you know.
No, it doesn't have to be engineering. I'm just curious. Yeah, like how people spent their time that they're locked at home.
Mm-hmm.
Matt, you last time we spoke, you're a big barbecue enthusiast, obviously coming from Kansas City, and you had asked me about barbecue. So I'm putting you on the spot. Did you have a chance to go to Baby Blues?
I haven't had a chance to. No, I was going to go study out in Venice for a day, but then we ended up redirecting to somewhere just in Silver Lake, so didn't get the chance to do it. It's sometimes, getting out to Venice without a car. I did it the other night, actually, to go see a friend's concert. And it is about an hour by the bus. It's a pretty straight shot, but getting out there during lunchtime can be a little bit rough.
Yeah, that's rough. That's absolutely rough to get there without a car. Yeah, Venice is. That's the funny thing about LA. You look on a map, everything seems really close, but it does take a while to get from one section of LA to another section. So it's definitely a little challenge. Well, good to know. We are Matt. You catch us in the throes of spooky season, and so we've been putting Emily on the spot for the last couple episodes. But I'm curious about you. Now, is Halloween a big deal in your group of friends? What's happening with you and your celebrations, your costumes? What's happening?
Oof. Unfortunately, when it comes to Halloween, I get rather boring. It's one of my least favorite holidays, to be honest.
It's Halloween where you get boring. That's just not normal, Matt.
That's up for debate. That's for sure. But the costumes never really did for me. I've always been a bigger fan of either the eating holidays that follow, Thanksgiving, Christmas, or 4th of July.
I hear you.
Halloween's an eating holiday as well.
I think what Matt's getting at is that they're more meat focused. I don't think there's like a meat centered Halloween. Halloween's more of like a candy sweet treats thing. And I'm with you. I'm with Matt on this one. I was never really I said this before. I'm never really into Halloween. It's not a thing for me. I think it's very much if you've got a sweet tooth, then you're really into Halloween.
Yeah, I have this rule for myself where I don't eat candy unless it's free. So Halloween's a really good day.
You don't eat candy unless it's free?
Just only on Halloween.
Yeah. And now the climbing gym has candy. So I just between climbs, I'm going to get candy every time.
I feel like now we should make it a thing where everybody brings you a piece of candy every time they see you, because then you have to eat it because it's free.
I will eat it. If I can eat it, I will eat it.
So Matt, it's now your job. Every time you see Emily, you got to make sure you bring her candy.
Yeah, I didn't know. Apparently this is like a exploit for Emily. Just always bring her candy. And
have we talked about this in the past, Emily? What is your go-to candy? Like if someone were to, if you're putting it on a wish list.
Definitely Sour Patch Watermelon.
Sour Patch Watermelon.
It's the best by far.
Did we have this conversation, or did people say this
so.
before? Sour Patch Watermelon. Why Sour Patch Watermelon?
Oh, it's just really good.
Yeah,
it's sweet, it's sour. They're kind of cute looking. It's good.
Matt?
When it comes down to my favorite candy, I'm gonna have to go with Toblerone. I always enjoyed
Fancy Swiss. What's up?
Yeah,
man?
I mean, hey, if we're gonna go for the best one, I'm gonna go with the fanciest one. I don't have it too often, but when I can get it, I'm always up for it.
I saw on social media somewhere that someone had painted parking barricades as like Toblerone, like it was a giant Toblerone that got broken up. It was one of the funniest things I've ever seen because like this big like parking parade. For me, I'm not a big sweets person, but I think when I get asked this, I think the thing that I see when I get excited about are 100 grands. If you guys have seen those or remember those, it's kind of an older school thing. What's that?
I don't think I've ever had that.
It's a chocolate bar, but it's in the inside, it's caramel, but there's like crispy crunchies on top. So it's got like the crispiness, but the caramel and the chocolate. And I think that is the go-to, but I'm never going to turn down a Snickers bar. I'm not going to turn down a Reese's. Those things are good.
Mm-hmm. That's a deep memory for me. Those 100 grand bars. Those are like early Halloweens. Those would be the ones everyone's like, what is this?
They come out on Halloween and people are like, what is this? I don't see this very often because it's not in the regular rotation. And I think that's what makes it good for me. All right. Well, as promised, I will give another clue. Do you remember my other clue? Because basically, Matt, you're joining us now. So for Matt to know what's going on, or if no one has joined us for all 10 of our listeners that don't listen to these outros all the way through, I have a set Halloween costume. It is part of my family's thing. And I had no role in deciding it other than I'm being told what to do. And I've given clues so far. Do you remember what my clues so far, Emily, have been?
I think the first one was that you're going to be wearing a hat.
A hat, right?
And then it involves something with cats.
It involves something with cats. My third clue is that I am a literary character. Now, don't say anything if you know what it is, but literary. So might have gone a step too far on that clue, but I'll let you soak it up for a little while. And that would be the final clue for today. And we'll come back and leave it as a cliffhanger for you all to our next episode, but to tease things that are happening this week in the Viterbi School of Engineering and also for the Office of Admission. We're in the middle of October, folks, which means we have nothing but events going on. As our usual, we have our virtual information sessions going on Tuesdays and Thursdays at 4:00. On Fridays, we have transfer information sessions. So Tuesdays and Thursdays are for high school students. Fridays are for transfer students. They fill up quite quickly. So make sure that you book that as soon as you can. Go to viterbiadmission.usc.edu/visit. On that page, you'll also see other events that are happening, such as our student-led live chats happening every other Sunday, different topics, different groups of students talking about different things. Find the one that resonates with you. If you miss one, you can watch the recordings there. And we also have faculty-led roundtable sessions on various weekdays, typically Mondays, Wednesdays, and Fridays throughout the month of October. We've already held computer science and astronautical and aerospace mechanical engineering, industrial and systems engineering. Those recordings are up on our website, but you can book the future ones for civil and environmental engineering, chemical engineering, biomedical engineering. Those are all coming up down the road. Make sure that you do that. Check it out. We have lots of events happening. And if you haven't started your Common App, make sure that you do that now. Go to admission.usc.edu/Common App, or just go to our website. We can link you straight off over to that. If you ever need anything, you have any questions, give us a call at 213-600-9919 or email us at vadmit@usc.edu. All right, Emily, Matt, so good to see you. I'm excited to hear about, at some point you're going to have your Halloween costumes. I'm assuming this is now going to be a big VSA thing where you all get dressed up at one day. So I can't wait to see it. I can't wait to hear about it because I know Matt's going to lead the charge. All right. Thanks, guys. We'll see you later.
Yeah.